Here's pre-calc. It's lecture, you could call it part 4 of 5.1.1. Again, we're working on these exponential, word problems with the modeling with exponential equations. So this one says Julie has a fresh cup of hot coffee that has a temperature of 180 degrees. The temperature of the room is 70. Sketch a graph of the temperature of the coffee over time. So I think I can do that. It has a temperature of 180 when it starts, but it's never going to get colder than the room. Like the cup of coffee is not going to just keep going down to the bottom like a normal exponential function would. It would go along towards 0. But so I think that's a reasonable. That's the model of the coffee cooling over time. So then it says let T equal the number of minutes after Julie pours her coffee, and let Y equal the temperature of the coffee. So we're going to have temperature of the coffee on the y-axis, and we're going to have time in minutes on the x-axis. 5 minutes after Julie pours her coffee, the temperature is 160. So get used to this. That I'm going to write that as an ordered pair. 5 minutes after she pours the coffee, it's 160. Okay, that's going to be useful to us. Write an equation to model the situation. So this is a tricky one because we've just been going y equals a times b to the x, and we know a is the starting point. So we want to plug in 180 there, but there's a little bit of a glitch with this one. This is an exponential function, but if you remember when we learned about the parent functions, this exponential function has, like y equals a times x minus, well, it has a k on it. Okay, it's lifted up. It's a function that got lifted up by 70, because this is 70 right here. So we don't want to put 180 in here for a. I mean, we want to, but we should not. We want to put 110 in here because we want to think of it as there was this function and it got lifted up. Like that's what has happened to this function. That's what happens when you add something to the end of it. So that's the way I think of it. So what I'm going to do is adjust my a to be, how far is that? 110. It's going to be 110. So I'm going to, well, because letter A said sketch it, so this is letter A right here. But then letter B said, well, it gave us this ordered pair. And I have to write my equation. So y equals, I'm going to say 180 minus 70, that's 110. The reason I'm saying that is because it's like when you take the 110 and you lift it up, because this thing, it has a, what do we call it, a vertical translation of 70. When I lift up my 110 by 70, it's going to make it hit at the 180, which we want. Okay, and then I want B, we don't know what B is yet. We've kind of got this. We want to know what B is, and we can always find B if we have an ordered pair. If we have everything else, then we can just use this ordered pair. So I'm going to plug in. We don't know B yet. We know X is 5. I'm just going to go crazy and start doing a bunch of algebra. So I need to use my calculator for simple subtraction. There's 90. Okay, I'm trying to get b to the 5th by itself, so I'm going to divide both sides by 110. And that gives me b to the 5th by itself. I'm just going to, kind of like I divided on top and bottom by 10, I'm just going to get rid of these 2 zeros. So now I've got 9 over 11. And then I'm going to 5th root both sides to get rid of the exponent. And then I'm just going to ask my calculator, what is the 5th root of 9/11ths? So shift, on my calculator, I hit shift and then I hit, you can't see these buttons anyway, but you're going to have to figure out your calculator, or you can maybe use Desmos or something. The 5th root of 9 over 11. You can also raise 9 over 11 to the 1/5 power if you can't figure out how to get the root thing to work. I got 0.9606. I'm going to call it 0.961. That's B. I'm going to start writing in this darker color too. Here we go. So I'm going to write y equals 110 because of the shift times 0.961 raised to the x plus 70. So this is the answer for 5-2 letter B. They wanted an equation. And so that's the equation that models the cooling of the coffee. So letter C says graph your equation. Okay, hopefully Desmos will follow me when I graph. I'm gonna go on I hope that you can still see. I graphed my equation. I just typed it into Desmos, and see, even though I wrote my starting point as 110, it's 110 but lifted up by 70, so that actually puts it up at 180 where it needs to be. And then I have this asymptote at 70, so it looks good to me. Okay, so that was what they asked me to do in 5-2. Letter C, does the equation match? Actually, honestly, my equation did not match because I had a 180 there at first because they tricked me. And that's what you would have found out if you were doing this in class. That's kind of the thing, is you have to realize that the starting point is 180, but since this graph is being lifted up by 70, you want to use 110 because 110 plus 70 gives you your 180. Anyway, we're going to say yes, it matches for letter C. Letter D says, what's the temperature of the coffee 15 minutes after it was poured? Justify your answer using the equation and the graph. So I think I just plug 15 in there, and that's how I can use the equation. And then I'll just ask my calculator. 0.961 raised to the 15. And I want to multiply that by 110. And I would like to add 70. And I got no, it's about 130 some odd degrees. And then I would like to look at the graph. So notice that we rounded this number quite a bit, so it might be a little bit off. Let's look at our graph. So if let's see. I just had 15. 15, I got 130.568, which is actually exactly 130.57. Well, I guess that's because I rounded the same way. So that's how I can check it, though. Yeah. And so I've justified my answer. So that's all I'm going to do for 5-2. I may or may not put another video for 5-3.